Okay, we're talking about perfect squares and perfect cubes. So when we talk about that, we just want whole numbers. So, and so if one side was 1 of a square, we know the other side would be 1. So 1 squared, which is equal to 1 times 1, will give us 1. Let's look at a cube. If it's 1, 1, 1, 1 cubed is equal to 1 times 1 times 1, which is still 1. So for this one, we would be talking about units squared. And for this one, we would be talking about units cubed. But we're going to forget about the area part of it because we're just going to talk about the numbers today. So let's look at perfect squares and perfect cubes. So I know 1, and if I square it, so 1 squared would still be 1. So now look, we're going to look at the square root of 1. So the square root of 1 is 1. So you're going to see a pattern here. So if it's 2, 2 squared is equal to 4. The square root of 4 is equal to 2. If a side is 3, 3 squared is equal to 9. We know the square root of 9 is 3. Are we starting to see a pattern? Squares and square roots are the opposite of each other. So if I square it, I'm multiplying it by the same number. If I'm taking the square root of that number, I'm taking it back to its origin. So let's try one more. 4 squared is equal to 16. The square root of 16 is equal to 4. Now I'm going to show you why squares and square roots cancel each other out. So let's go back down here to the square root of 4. The square root of 4 can also be written as the square root of 2 squared. If the square and the square root cancel each other out, that will leave us with 2. So the square root of 9, that is equal to the square root of 3 squared. 3 times 3 is 9. The square and the square root cancel each other out. The answer is 3. The square root of 16 is equal to the square root of 4 squared. The square and the square root cancel each other out, and the answer is 4. So now let's go on to perfect cubes. So we know with perfect cubes, we are talking about 3 numbers multiplied. So we're going to take the number, we're going to take the number cubed, we will take the cube root of that number. Now remember, if it's a square root, we don't need to put the 2. It's implied that it's a square root, but if it's anything other than a square root, that number has to go through there, and then the answer. So let's follow. Let's start 1. 1 cubed is equal to 1. The cube root of 1 is equal to 1. So let's take 2. So 2 cubed is 2 times 2 times 2, which is 8. So now we know that the cube root of 8 is equal to 2. Let's take 3. 3 cubed is 27. The cube root of 27 is equal to 3. It goes exactly backwards. It can go forward, it can go backwards if you get confused. So let's look at what we did before, how we broke this down. Let's start with the cube root of 8. We want the cube root of 8. If you're unsure of what the number is cubed, go back and do a factor tree. So let's do a factor tree of 8. 8 is 2 times 4, which is 2 times 2. So we know that the cube root of 8 is 2 cubed. So if the square and the square root cancel each other out, the cube and the cube root will cancel each other out, so your answer will be 2. Let's look at it for the cube root of 27. Once again, do a factor tree of 27, which is 3 times 9, and 9 is 3 times 3. So we know that our cube root of 27 is the equivalent of 3 cubed The cube root and the cube cancel each other out, and the answer is 3. That's how you find your perfect squares and your perfect cubes.